to fill this knowledge gap before to exploit the fully benefits from Industry 4.0. In any case, the Industry 4.0 has several benefits because having a more sustainable and reliable production plant for sure improve the efficiency of existing plants and contribute to the economic growth and to market diversification. Another important benefits of the Industry 5.0 is the creation of new job market, because a new type of work are required for the full application of these technologies in industrial plants. And generally, the Industry 4.0 promote the application of innovative technology inside the industrial automation. So, do you have any question about Industry 4.0 and Industry 5.0? No? Everything is clear? Okay. If just-in-time marketing is sustainable, because in Industry 5.0, basically we produce just what the customer buy. So we avoid the creation of a warehouse of products in order to that we need in the traditional production system. So the reduction of warehouse of goods reduce the waste. Yeah. The idea is to produce for the customer higher quality products that they need, trying to reducing the energy to produce these goods, of course. And so producing only higher quality product reduce the waste, and so improve the sustainability of what we are doing. Sorry? Robot manufacturing system, but the most important part in just-in-time manufacturing, we need a strong integration with the supply chain, because when we start to produce something, we need to have all the sub-components to produce these goods. So we need to be very connected with the supplier of the supply chain. Yeah. Welcome. Yeah.
Sir, as you mentioned, in Industry 5.0 means that it has less security as compared to other like Industry 3.0, 4.0. Then, like in terms of cyber risk or the data loss or something, then why is it still preferred?
Sorry, what's the question?
Why is it still preferred in the market? Like why nowadays people go for the Industry 5.0?
That's a good question. The Industry 4.0 and 5.0 is based on the interconnection of devices. And with respect to traditional automation, where the elements of industrial automation, sensor and actuator, are segregated, so are not exchanging the information with the rest of the world, and implicitly are implicitly secure because they are not exchanging data with the external system. The Industry 4.0 and 5.0 open the industrial plants to interaction with the external system. The reason for this is in order to be able to exploit for example, some technologies like cloud computing, that require the interconnection of industrial plant with external system. Because in industrial plants, we cannot put server, advanced server with a lot of computational power inside in the production plant, because a production plant is an harsh environment. So basically, we cannot put traditional PC inside an industrial plants. And so the idea behind Industry 4.0 and 5.0 is to collect the data from the plants using IoT and sensor and transmit this data outside the industrial plants where the computational power is available, and to perform advanced analysis like predictive analysis, machine learning, optimization outside the industrial plants. So in this way we can exploit the possibility to use advanced machine learning and AI technique also in industrial plants. But the problem is that we are opening the industrial environment to possible attack, because we connected the industrial plants with the external world. That's one of the challenges of this approach, of course. And just to solve partially this problem, nowadays, probably as I show you in the next days, we are moving to the so-called edge computing. So basically, not all the analyses are performed in cloud, because of the problem of data security, access to data of the plants. And so we try to move some of the, or at least a part of the computational power inside in the industrial plants again. Okay. Any other question about this part? We can move to give, if you have time, to give a look more in detail to the industrial automation, if it is okay. Okay, now I try to give you some more detail about the industrial automation and the basic element of an industrial automation system, or at least of a traditional automation system. You probably know the industrial automation, the origin of industrial automation was in the past. Basically, the first large automated system was organized by Henry Ford, the founder of Ford Motor Company, at the beginning of the 20th century in the United States. Basically, we have to clarify a little bit the terminologies, because in English, with the same word automation, we can identify two different processes. The automation basically is the idea behind the assembly line. The idea of the assembly line is to divide a complex job. For example, the construction of a car, in the case of Henry Ford, is to divide a complex job, a complex task, in a set of repetitive, very simple jobs that can be performed by a single person. So the goal of the automation is to reduce the time required to produce a goods in order to produce more goods, more products in the less time, and to simplify the process of producing this good. So we don't need very people working in an assembly line with a very good competence, because the people working in an assembly line has to do a very simple job in a repetitive way. With the same word, in English, we identify the automation, also the science and the technology, we try to automate, or at least to replace the human labor in the assembly line using the machine. The word is the same, the target is different. The goal of the automation, of industrial automation, is to reduce the presence of people on the assembly line by replacing the people with machine, robots, and so on, in order to reduce the cost of the person involved in the production of the good, in order to improve the security, because if I replace a person with a machine, the production of the good is more safe from the point of view of a person, because I have less men involved in the production of the goods. Processing the information coming from the assembly line, and in order to process the information from the assembly line, I need to install a lot of sensors to monitoring the different part of the production line. And this can, and in particular the automation has three different goals. The first is to automate the process to produce the products. How can I optimize the process? We can optimize the process to produce our goods by reducing the energy required to produce an object, to reduce the material I need to produce the same object, and try to reduce the time by replacing the man with a machine. The replace of machine, of the man, of people with a machine, improve also the quality of a good I'm able to produce, because a machine do the same job in the same way 20 hours a day without making any error, generally. The usage of a machine enables the possibility to reduce the waste. Again, a machine generally is more precise than a man, of a person generally. And so I reduce also the waste in the production of goods. I can improve also, for example, the safety of the production, and generally I'm faster in responding to the request of the market, because I can modify faster the assembly line in order to respond to a request of my customer. At the same time, the automation allows to optimize the assets. What are the assets in an industrial plant? The machine. Basically, the machine and the goods are using for the production of the goods. So using the automation, I'm able to optimize the way I can produce the goods. And so I can reduce again the cost, the final cost of the products. Using the automation, as I mentioned before, I'm able also to reduce the cost of a person, because of course I replace person with machine, but generally cost less. And I can use the person in order, the people, in order to perform high quality job inside an assembly line. For example, for sell the products or to maintain the machine and the system. When we speak of automation, of a science for replacing people with machine, we need to make a distinction between two different type of automation. The so-called factory automation. Basically, a factory automation is the automation of a factory where the job is organized as a set of repetitive activities. An example of typical factory automation is the car manufacturer. When I have to build a new car, the construction of a new car is basically a set of repetitive, simple job I perform. And in this case, the manufacturing environment in the factory automation is basically constituted of a machine, assembly line integrated with a machine, and robots that work in different area of the company. The target of factory automation is to increase the speed of production, reduce the waste, and to perform a diagnostic of the system. In this case, it's very important to identify failure using, for example, predictive maintenance, because if I'm able to predict a possible failure on assembly line, I can reduce the time to maintenance the line, and so my assembly line is more efficient. And so the target of factory automation basically is to reduce the cost of the production by organizing in the best way the production system, and to reduce the time. The time of elaboration of the time of the assembly of the object, and the time to move the object from one area to another one. One example of factory automation is the car manufacturer, but that's not the only type of factory automation I have. For example, a factory producing steel is another example of factory automation, or the automated logistic is another example, typical example of factory automation. The second type of automation is called process automation. What is a process automation? A process automation is basically a series of mechanical, electrical, physical, or chemical operation that is used to produce, to manufacture, or to distribute something on a larger scale. Basically, a typical example of process automation is oil and gas, a refinery, for example. I used the oil in order to produce gasoline and so on. That's another example of automation. And as you can see, process automation and factory automation are very different type of automation, because the target they have are completely different. in one case, the target is to produce an object, for example, a car, or a semi-product like steel. In the case of a process automation, the target is to produce and to elaborate, in general, a chemical or a thermal work. And the two type of automation are different because the company are completely different. For example, you can see generally a refinery is a very large plants that cover, for example, an area of several kilometers square. A general car manufacturer plants is limited also in the size of a construction site. The main target of the process automation is the safety. So basically we need to produce in this case the gasoline in a safety way, and try to reduce material and energy usage. So the efficiency of the plants. Other example of process automation are, for example, chemistry, the polymers production, and so on. I have another particular example of process automation. The power distribution. If you think the power distribution system is another example of process automation. Because why is a process automation? Because the target of a distribution system operator of a utility, the target is to distribute the energy produced by power plants or by renewable resources nowadays, and to route this energy to the final customer in order to reduce the energy dispersion due to the cable and to improve the reliability of the service to the customer. So the distribution of the power on electrical grid is a typical example of process automation. So the distribution of electricity has a lot of technology in common with the rest of process automation example I showed before, with a refinery, with oil and gas, and so on. Basically, we use the same technologies for the automation of this kind of system. But the world is more complex than white and black, because we have different type of factories in which the process automation and the factory automation has to coexist in the same plant. A typical example I do during my lecture is, for example, the production of medicine, pharmaceutical sector. In a pharmaceutical plants is a mix of both the technology, automation technology, because in a pharmaceutical plant I have to produce the medicine, so I have the chemical reactor, and I have to package the final product. So the process automation and factory automation in a pharmaceutical plant are coexisting together. And that's the case of large part of a general industrial plants. So, but now give a look more in detail on how an industrial environment is organized. So in this picture you can see general industrial plants. as input of industrial plants, generally I have a supplier of products, of some components. At the end of industrial plants, I have the distribution system used to distribute my components, my products. And industrial plants inside, in the industrial plants is organized in several processes called area. The factory is divided in different processes called areas, and inside of each area I have different machines that perform the job. Each machine that performs a job inside an area is called cell, working cell. Next, tomorrow, we see what is inside inside a cell. Okay. See you tomorrow.
See, afternoon you'll have classes as per the timetable shared with you. Thank you.